Okay, let's think of a rolling ball or a cylinder down from an inclined plane. The center of mass of the ball, let's say, is doing actually a linear motion here. But at the same time, the ball is doing a rotational motion about its own center of mass. If the linear velocity of the ball is 0 at the top, and it has a potential energy mgh, then at the bottom it has a kinetic energy where we find from 1/2 mv squared. And here we should also consider the rotational kinetic energy, because it also rotates around its own center of mass, which is equal to 1/2 I omega squared.
When working with rotational motion, we always have to consider central angles within the motion. As you probably know, central angles are measured in radians. In this case, the radian measure would be the arc length, in this case the rotational displacement, over the radius of the motion, which is shown here. And by deriving this, we can find that the displacement is the radius times theta, the angle measure in this case. Then the rate of change of displacement would equal the radius times the angular velocity, which in this case is the rate of change of radians, the rate of change of angles, which would give us velocity equals the radius times the angular velocity. And then the rate of change of velocity for angular motion would be the radius times the angular velocity, the rate of change of angular velocity over time, which would then turn linear acceleration into rotational acceleration, so alpha times the radius of the circle. These two linear quantities are also commonly referred as tangential quantities.